It is mechanical, right? Like, oh, like bile is a chemical. The idea here is that it actually breaks it into using detergent-like properties. It actually breaks the fat globules into small fat droplets. And so bile is mechanical digestion of lipids. So lipases then do the work, right? They can bind to the substrate and break it down into smaller particles so that it can be used by the cell, okay, the cells in the body. Okay, what's another function of the liver?
Filters.
Yes, so it filters toxins and breaks them down if it can. Filters, breaks down toxins. And so when we absorb our nutrients, sometimes we also absorb toxins. And the example given in the video was alcohol. So alcohol can actually pass right across the surface of the stomach. And then when it gets into the blood, it then goes to the liver, and the liver will start to break it down. And so we mentioned that if it cannot break down all the toxins, you can actually get damage to the liver. And so sometimes when you're exposed to environmental toxins, what they'll do is they'll do like a blood test, and they'll look for your liver enzymes. Is that in the blood? Does anybody know? Does anybody work at Interpath? Well, so like say, for example, you think you've been exposed to heavy metals like mercury. So you are working in a chemical plant, and they are afraid that your liver is shutting down. And so they'll look at the liver enzymes to see whether your liver has been damaged. So the liver not only breaks it down, but it can be damaged by those toxins. And so it can also be damaged by excessive alcohol, and it can be damaged by viruses. So the hepatitis virus specifically attacks those liver cells. And so what happens if the liver becomes damaged by the toxins? Does anybody remember what is the end thing that happens?
Cirrhosis.
Cirrhosis, okay? So damaged liver cells die, right, and are replaced with simple connective tissue. And this is referred to as cirrhosis. Right. And one of the precursors to cirrhosis is what is sometimes referred to as fatty liver disease. So fatty liver disease is a precursor. So that's what kind of you might be diagnosed before you have liver failure due to cirrhosis. You might be diagnosed with fatty liver disease. And this is where the liver cells become stressed, and they turn the nutrients that are coming into the liver to be processed, they turn that nutrients into fat. So even if it's like protein that's coming into the liver, they'll actually convert that protein to fat, and then the liver cells will the whole liver will fill up with fat. And you can have alcohol induced fatty liver disease. So if you're an alcoholic, you can get this. But there's also people that get it who are not alcoholic. And so there's some question as to why some people are more likely to get it than others. And they think that there might be a genetic component to it, why you might get this. If it tends to run in families, for example. It also might be environmental. So like, for example, if you're exposed to toxins in the environment, or if you have viruses. Viruses can also lead to fatty liver disease. Okay, so the other thing that it does is it stores glucose as glycogen. And so the hormone glucagon actually causes glycogen to be broken down by the liver cells, and glucose is released into the circulatory system, and it causes the elevation of the blood glucose levels, okay? So this is insulin causes production of glycogen. Glucagon causes breakdown. So glycogen is the equivalent of starch in animals. So plants do not store their glucose as glycogen, they store their glucose as starch. So we don't have starch, but we have glycogen, and it's very structurally similar to the starch that you find in plants. It's just a way for us to store it so that we can use it if we need energy. The other really interesting thing about the liver in terms of carbohydrate metabolism is it converts, so we'll talk about the conversion of other monosaccharides like fructose into glucose. So our cells in our body can only use glucose for energy for the most part. They cannot use fructose and galactose and other types of monosaccharides that we find in our food and in nature. And so fructose is metabolized in the liver, not in the cells. So fructose has to be converted, that's fruit sugar, has to be converted into glucose in the liver before it can be used throughout the rest of the body. And so this is one argument for why high fructose corn syrup is a really bad dietary thing to have, because if you're drinking soda pop, for example, that contains, most of them, unless they say they have cane sugar, contain the high fructose corn syrup. And so this is going to stress out your liver, and you don't want to stress the liver out, right? All that fructose has to go to the liver, and it has to be converted into glucose before it can be used by the rest of the body. So that's like kind of an argument for why having high levels of fructose in your diet is not necessarily a good thing, okay? Probably the amount of fruit that you eat, if you're just eating whole fruit, is not, or the amount of fructose that you get. So they always say that you should eat your fruit rather than drink your fruit, right? Because fruit, like an apple, has lots of other good things in it. It also has fiber, but if you're just drinking apple juice, concentrated apple juice, then it's just gonna have a lot of sugar in it. Okay. The other thing that the liver does is it uses amino acids in the blood to produce proteins. Specifically, some really important proteins are blood clotting proteins. So remember that when we talked about blood, there was like 13 different blood clotting proteins that are numbered Roman numerals. And there's a cascade of chemical reactions that occur to get fibrinogen to come out of solution and form fibrin, which actually then catches the red blood cells and keeps them from leaving the circulatory system, like in a massive hemorrhage, okay? And you can have internal hemorrhages as well that you might not even know about. So you could be losing blood internally if you don't have the blood clotting proteins that are there. So if you have internal damage, you can bleed internally. And so that's an important function of the liver. The other one is that it produces albumin. And albumin is a really interesting protein, I think. I'm kind of fascinated with albumin because it's found in egg whites, right? But it is also found in your blood. And its function seems to be that it maintains the osmotic pressure in the circulatory system so that when you lose water in the capillaries, then at the veinal ends, the capillaries will suck the water back out. So albumin is used to maintain the osmotic pressure in blood vessels, in capillaries. So it doesn't really leave the capillaries, it's just used to maintain the osmotic pressure. So what would happen if you didn't have enough albumin in your blood? What do you think would happen?
Water?
Yes, you would have water retention and you'd have edema, right? So you'd have swelling. So we talked about lymphedema, for example. So you'd have swelling of the tissues. And so, you know, sometimes that happens in people when they get sick, is that one of the first things that they'll notice is like, oh, one arm just swells up or one leg just swells up. And they don't know why, and then they can go in and they can try to figure out why. So the liver not being functioning can also lead to swelling because you'll get fluid buildup in the body.
Does something happen when women are pregnant that causes them to have a lack of albumin? Is that where their water retention comes from?
I think their water retention mainly comes from the fact that they have like 30% more blood in their body when they become pregnant. And so they just have so much more blood, I think, is why you get loss. So the blood pressure, so there's more blood in the blood vessels, so the blood pressure forces fluid out. But I don't think it has to do with the albumin necessarily. Okay. So that would be a major function of the liver. And then the liver also, oh gosh, I just lost my train of thought. Okay, well, we'll go on to the functional unit of the liver. Maybe I'll come back to that. Okay, so if we look at the liver, what cavity does the liver sit in? Abdominal, which is also called the peritoneal cavity, right? And so what organ sits right above the liver, like right there? The diaphragm sits right above the liver. And so there is a ligament that holds, the falciform ligament actually suspends the liver from the diaphragm. And you'll notice here that the right and the left lobes are different size. And you'll notice here that there's also a picture of the gallbladder. So the gallbladder is on the posterior surface of the liver. And then this one's really interesting. I think this ligament's very interesting. This is actually, and this will be important when we look at the fetal pig, because this is actually the umbilical vein. And so when you look at the fetus, any blood that is coming back from the mother goes to the fetal liver first. And that makes sense because if the mother's blood is coming in and it has lots of nutrients in it, and maybe even some toxins, it could have alcohol in it, the blood needs to go to the liver so that it can be modified before it is sent out to like the brain, which is very sensitive to different levels of nutrients, including glucose. And so this is actually, this ligamentum teres, or the round ligament, is actually the leftover umbilical vein. Okay. So if we look at the backside, right, we see that this is the gallbladder. And they mentioned in the video that sometimes the ducts from the gallbladder to the duodenum can get blocked with gallstones, which is due to a diet that is high in fat, and specifically cholesterol. So cholesterol and bile salts kind of get built up and they produce gallstones. So if you were to have your gallbladder removed, then you would want to limit the amount of lipids that you ingest. But it's kind of interesting because the lipids will actually move more quickly through the digestive system without the gallbladder. And so it might mean that you eat lots of lipids and then you'll like have diarrhea, right? Because all the lipids are moving really quickly through the system, kind of lubricating it. And so that might be a symptom of having lack of bile stored in the gallbladder. Okay. So if we look at the microscopic anatomy of the liver, we have what are called the working units, which are called the liver lobules. So these are microscopic. They're about the size, your book says, of a sesame seed. You can see them with your eye, but you can't see the details of it. So this is the working unit of the liver. So it's different than just the lobes, which would be the big right and left lobes, okay? They're also hexagonal in shape. which means that they are six-sided. See if I can do my hexagon. 1, 2, 3, 4. There we go. So that's hexagon, okay? And at each corner of the hexagon, we have what is called a portal triad. So portal triads are at each side. So that would be like there and there and there would be a portal triad. In the center of the hexagonal unit, we have the central canal. And the central canal connects to the hepatic vein. And the hepatic vein is carrying blood that has been processed by the lobule. So the hepatic vein carries blood out of the liver, so which carries processed blood out of the liver. Okay. So let's look at the portal triads. So there's 3 vessels. We have what is called the portal arteriole. So an arteriole is carrying oxygen-rich blood. And so this is actually going to nourish, it's going to give the hepatocytes that line the inside of the lobule oxygen so that they can do their work, right? So this provides oxygen, so this is O2-rich blood. Okay. We also have the portal venule. And remember that that lacks an I. And the venule contains nutrient-rich blood. And this is coming from the small intestine. So what is the circulatory system that connects the small intestine to the liver? Does anybody remember? What connects the small intestine to the liver? Hepatic portal system. Okay, so this is part of hepatic portal system. And it's called a portal system because it's not going back to the heart. It's just going from one organ to the other. So from the small intestine to the liver. Okay. Then we have the bile duct. And this is transporting bile, obviously. Okay. In the hepatic portal system, not in the portal system, sorry, in the liver lobules, we have hepatocytes. So we have hepatocytes. And so these are liver cells that do all the work. So everything I just mentioned about what the liver does, breaking down toxins, storing glycogen, breaking down glycogen, releasing glucose, producing proteins, those are all done by the hepatocytes. Okay, so let's look at an image from your book that has this, and you should be able to label this image for the midterm. So this is the liver lobe. And then if you look at it microscopically, these are the lobules. So this is the lobules, and it's showing the central canal. Here they call it the central vein, but I thought it was called the central canal. Sorry, I guess it's called the central vein. Central canal, central vein. These are the triads right here. So this is the oxygen-rich blood. The venule has a larger diameter and a thinner wall. And then you have the bile duct. And so what happens is that blood that is coming in via the vein then gets transferred, and it passes through these series of canals. And you'll notice that what is lining the canals are the hepatocytes. So these are the hepatocytes. So sometimes they liken it to a book with many pages. So what happens then is that if this blood has lots of glucose in it, these hepatocytes remove the glucose and store it as glycogen, right? They remove the toxins, they store the toxins, they remove the amino acids, they produce amino acids, and then that all gets transferred to the central vein or canal, which then connects to the vein that leaves the liver. And then it's going to go back to the heart, right? Pumped out to the lungs, back to the heart, and then distributed out to the body. So remember that one function of the bile was to emulsify or to break down the fat globules. So this just shows how the bile salts bind onto it and break it into smaller pieces. So this is a diagram that shows the function of the bile. And then enzymes can get in there and then break down the lipids. Okay, so that's it for the liver. So there are two illnesses, digestive illnesses, that for some reason seem to be more common today, and we don't know if maybe why that is. Some people argue that the wheat has really high gluten in it for celiac disease, because gluten makes the wheat it kind of sticks together, and so it is what is really found. There's lots of gluten in like white bread that rises really well and is like really airy and light. That would be bread that has lots of gluten in it.
My doctor said it was because we haven't, our bodies aren't made to process as much wheat and gluten and everything that we're taking now. So now pasta, you're eating pasta, bread all the time. And back then you would eat bread 2 meals a day. You weren't taking as much of it as we are now.
There's also some evidence that the strains of wheat that they're growing are higher in gluten. So in the past, if you're eating pasta, it wouldn't have as much gluten in it as it does today. Okay, so celiac is specifically, both of these are actually autoimmune diseases. Celiac specifically tends to be a gluten allergy that causes inflammation specifically in the small intestine. I know some people that actually have this as well, intestine, and it affects their skin. So for example, they'll get rashes if they eat too much gluten. But the real problem is that when it gets into the small intestine, it causes the villi to break down. And so the villi are destroyed. And this causes a couple of things. This can cause bleeding, which could lead to anemia. But also prevents absorption of nutrients.
How does it do that?
Because if you don't have the villi, if the villi are destroyed, there's not as much surface area, and then you can't get the nutrients to come in. And you could actually also, sometimes it's called, I need to do a little bit more research on this, but sometimes if you have bleeding in your stomach, that also means things can get in there. So bacteria can get into your blood, and it's sometimes referred to as leaky gut. So things can get in that ordinarily the villi would screen out to. But you also can't absorb nutrients across because the villi are destroyed. Okay. So Crohn's disease is not related to gluten necessarily, or doesn't seem to be. There's lots of controversy about how these are related. And it can be anywhere in the digestive system. So can cause inflammation anywhere. So it could be in the mouth. So anywhere in the alimentary canal. It could cause problems in the stomach. It could cause problems in the large intestine, right? And so sometimes this has influences in your digestive tract, and it's related to irritable bowel syndrome. So sometimes bleeding can occur, but also the bowel can, or your intestines can contract and cramp up, and it can be very painful. And so IBS, irritable bowel syndrome, is associated with Crohn's. Okay, any other comments on that? Okay, so we're going to start chapter 24 today, and we're going to talk a little bit about nutrition. Now, when we talk about nutrition, we can talk about how we need building blocks, right? So nutrients are building blocks for producing new tissue and repairing damaged tissue. And so my daughter just recently had her tonsils removed, and she was in a lot of pain, and she didn't want to eat anything, right? She just wanted to, what did we get her? She just wanted to like eat or drink sweet drinks, right? Sweet cold drinks, right? And the doctor said, if you do not eat protein, your scabs, which were just humongous, and it's interesting, the scabs in a mucous membrane look entirely different than the scabs on your skin because they're soft tissue scabs and they're like yellow. And so they look really weird. Like it actually looks like infections, but it's actually big scabs on the back of her throat. And so he said that if you didn't take in enough protein, the tissue was not going to be able to repair itself, and you were going to be in a lot more pain for longer periods of time. So this is the idea that we have to take in protein in order to repair damaged tissue, like having your throat cauterized and your tonsils removed. And if you don't take in the protein, then the tissue cannot repair itself. So that's a good example of how you need nutrients. And so we had to force her to drink protein drinks, and he wanted her like on bodybuilding protein drinks in order to repair that damaged tissue. We also need energy. And when we talk about nutrients and energy, we talk about calories, right? So the big C, like how many calories does this soda pop contain, right? So that's a measurement. And when we measure it, calories is actually the same thing. It's really kind of weird, but it's the same thing as a kilocalories. Oops. Spelled that wrong. Calorie.
I noticed in other countries, their nutrition labels, they actually put it in energy.
Mm-hmm. We've been getting those snack rates once a month, and they have the nutrition facts, and they're measuring energy on the back.
Oh, interesting. Because actually a lot of your nutrients can be converted to energy, right? So you can take in proteins, and it can be converted to fat. Protein can be converted to fat. Protein can be converted to glucose and then used to produce energy. So that's probably why. So this is actually the same thing as a kilocalorie or kcal.
Or they just don't want you to feel like you're eating a bunch of crap.
Right.
Like trying to trick you into, oh, it's energy.
It's energy, yep.
5,000.
I better eat a lot of this candy.
Score!
Okay.
Level up.
So in nutrition class, you probably learned what a kilocalorie is a measure of. Does anybody know? Okay. Amount of energy required to raise 1 kilogram of water (1° centigrade.
And that, you said kilocalorie?
That's a kilocalorie. So 1 kilocalorie is the amount of energy, so 1 kcal is the amount of energy required to raise 1 kilogram of water 1 degree Celsius. So that energy is absorbed by the water, right? And then it causes the molecules to move faster. And if it absorbs enough water, then it causes the water molecules to break apart, and the water turns into steam and it evaporates, right? But that is the definition of a kilocalorie, which is the same thing as the big C calories, okay? So much of the things that we take in are actually used for energy, not necessarily for nutrients. So lots of the stuff that we take in, because we are endothermic, which means that we use metabolism to regulate our body temperature, then we use a lot of the things that we take in for energy, not necessarily for building blocks. Okay, so we can also talk about macronutrients. So these are things that we need a lot of. And so these would be like carbohydrates, proteins, and lipids. We also need a small amount of micronutrients. So these would include vitamins and minerals. And we'll talk about the role that vitamins play and the role that minerals tend to play in the body. Okay, so that's just like how much you take in. So obviously we take in more starch than we take in vitamin C, right? We need more starch to fuel our activities than we would need vitamin C to produce collagen, for example. So vitamin C is actually functions as a coenzyme. Okay, then we have what are called essential nutrients. So essential nutrients are those which you have to have in your diet. So your body can either not make the essential nutrients, so maybe it can't make it, or it can't make it fast enough. So this is must be in diet. Right. So there are 8 essential amino acids in humans, and what's really interesting, I think, from an evolutionary perspective, is that there are different essential nutrients, specifically like amino acids, for different species. And so like if you took animal science and you're like looking at a guinea pig and its diet and you're trying to figure out how to make guinea pig food, right? You would have to, it would be different than say for a cat or a dog, right? They would have different essential nutrients. And so it's kind of interesting what animals have to get what from their diet. So I know that guinea pigs, for example, have to have vitamin C, so you have to give them fruits, right, in order to eat, or they'll suffer from scurvy just like we do. Okay, so these must be in the diet. It doesn't mean that these are any more important, it's just that these are essential to your diet because the body cannot make them. Or make them fast enough. Okay. So when we talk about nutrition, sometimes we say that a person is malnourished. So what does mal mean here? Bad, right? So not the right nutrients. Okay. We can also say that a person is overnourished. Does that mean that they get too much nutrients? They're overnourished. What does that generally relate to? Obesity, right? So they're getting too much energy, right? And that extra food that they're taking in is turned to fat. And so this is too much energy.
I think I'm going to start saying that.
Right? I'm overnourished. I have too much energy, it's all stored as fat, right? So in our society, we have this really weird combination where you can actually be overnourished and malnourished at the same time. So you can have a diet that is high in fats, for example, and carbohydrates, like you could eat lots of potato chips and drink lots of Pepsi, and you can have so much energy coming, that you're storing as fat, but you don't have the right nutrients, and so you're unhealthy, right? Maybe you don't have the right proteins in your blood. Maybe you're anemic because you can't produce enough hemoglobin if you don't have the right proteins. In most places, malnourished goes with being undernourished. So if you think about famines, okay, this is not enough energy. And where this one, overnourished, is associated with obesity, undernourished is associated with tissue wasting. So I'll put obesity here. This is tissue wasting. So literally, you will, if you're undernourished, if you're not taking in enough nutrients, you will start to break down protein. You will start to use your muscles. You will start to break down the tissues and use that protein, and you'll convert it into glucose, and you'll convert it into energy, just simply in order to maintain your body. So protein is converted to energy. And that produces byproducts that are not necessarily very good, can cause problems with your kidneys. Okay, so that would be like in a famine situation. So one of the interesting things about children that are undernourished, we think about, sometimes you see these children and they have these big bellies.
They eat lots of carbohydrates.
No. So the big belly actually has a name, and it's called, I forgot to, Quagior, let's see if I can spell it. So the interesting thing about this is that it actually is due to swelling, okay. So this is the swelling of the belly. So they're not even getting enough carbohydrates, okay? So this is where they're undernourished. They're not even getting like rice, right? They're not getting enough energy. So what this means is that the albumin in their body gets turned to energy in their blood. And so what happens when you don't have albumin? You get water gain, so you get swelling, right? So that swelling abdomen is due to water. It's not due to fat. It's not due to carbohydrates. It's due to lack of being undernourished and lack of energy, and so that their body is just and they get really skinny and they have the big bellies.
It was told to me the opposite. Somebody told me that it's because they eat so much starch in their diet that it causes them to swell from irritable bowels. So I heard it in a completely different way.
I'll have to look into that. I've never heard of it that way, but I think they're like, they don't even
wheat and
rice and stuff. Yeah. But
isn't that just constipation? Wouldn't that be just?
Yeah, I don't think that the bowels could swell big enough to cause the big abdominal bloating that we see. Yeah. Okay. Was that in your nutrition class?
No, actually, my friend Christine took A&P from the other teacher, and she was my roommate, and she told me that when she came home.
Oh, interesting. Okay. I'll look this up again and make sure that that's not a
That's why I
component
thought
of it.
that was the answer.
You're like,
oh.
Okay. So, this is the new healthy eating pyramid. This might be familiar to you. It doesn't look familiar to me at all from a perspective of like what I learned in school, because generally what was on the base of the pyramid were carbohydrates. So this is the old food pyramid. Okay. So were you guys raised with this one?
Yeah.
Okay. This is the old one, right? This is totally wrong, right? And so they think that this actually might be the reason why we have diabetes, why we have obesity, and why we have Alzheimer's. They're all kind of three related, right? So we have this epidemic. And the reason is that we all kind of believed that the basis of our food chain should be grains. And those are carbohydrates, right? And then you'll notice up there that we use fats and oils and sweets. That's important, sweets, but really not very often, right? And but our basis is the carbohydrates. Okay, so let's go back to the one that was published recently. Okay, so if you look at it, oils actually make up a big component. So this anti-fat push was the idea is that all fat was bad because it might lead to cardiovascular problems. But you'll notice that the fats that are shown here are examples of oils, which are actually unsaturated. And so now they believe that unsaturated fats actually help to keep your cholesterol levels normal. And so that should be a major component. So for example, you could eat lots of nuts and oils. So they have nuts up there, but those also have a lot of oils in them. And notice that there's no white pasta here, right? Whole grains, and it's only half of the amount of nutrients, okay? And then also notice that all this stuff is up here. The white rice, white bread, pasta, sweets. Question?
You should never eat pasta? What's so bad about red meat?
It has saturated fat in it, and saturated fats could lead to higher cholesterol levels. So some people in particular have a hard time with having excess. The saturated fat also in butter. Now notice that there's no trans fats in here. So there's no margarine. Margarine is actually worse than butter because it causes the production of a type of trans fat which actually elevates cholesterol level. So the whole, your grandma using the margarine instead of the butter was a big, she shouldn't have been doing that, right? Grandma should not be using margarine. She should be using real butter.
Margarine uses margarine.
Okay. So they think I am kind of down on the government because they think this is too complicated for people to understand. So this is what they have given you instead. Okay. Because people just can't understand that other one is too complicated.
Yeah, because everybody should drink a glass of milk.
But
with every
see,
meal.
now most people would take this the wrong way. They're going to see that big chunk of protein and think red meat.
Yes.
Eat lots of red meat.
Yeah.
That's what they're going to see, and drink lots of milk and.
And I don't eat fruit with every meal. I love fruit, but it ain't on my plate every time.
And fruit actually has got fructose in it, which is hard on your
Fruit
liver.
is also very expensive. So.
That's true.
Yeah.
We're all falling on a budget.
I know we try to go
Apples, we go to the farmer's market, had really good deals.
When we were on fire, and they'd be like 20 bucks a day to buy food, and I would just buy apples. It was I get super full of apples, and then we can pocket the rest of the money.
Okay, and we now know that dairy, we do need calcium in our diet, but there's other places to get calcium because a lot of people are actually lactose intolerant. Well, not a lot of people in our population, but in African American populations and Asian populations, people are generally lactose intolerant.
Now, I read that this whole Got Milk campaign was like a thing from the government to try to get us to buy more milk because we rely so heavily on cow farming. Do you think that's true? Or do we actually need that much?
I think that we need calcium, specifically certain people. So children need calcium.
Right.
And they have really good evidence that if you're white and you're a woman and you're above the age of 50, you need to take calcium supplements because of osteoporosis.
I read an article saying that because the GMOs, they were putting hormones in the cows and they were creating so much milk, they were creating so much milk that we were throwing milk down the drains, and so that's why they did the Got Milk because farmers were losing money and it was no.
Yeah. But also to touch on if you're a woman and white and over the age of 50, I kind of had this impression through going through some of these classes that, especially being a woman, you're not supposed to drink as much milk because isn't it bad, too much calcium buildup? Isn't it
European descents have been drinking milk for so long that it doesn't really matter. But if you're like from Africa or something like that, then you can't process it.
You can't process it. But she's talking about like I have heard of people, and I don't know if calcium buildup is all that bad, but I've heard of people that drink so much milk that they actually get calcium buildup like underneath their skin, and that's weird.
My whole
But
life
I don't think that
I've
actually
been
is
calcium
bad for you. But I think that osteoporosis is a real issue in a certain population of people.
Because I thought after like the age of 30, women couldn't use calcium anymore. That's
Well,
why they drink so much.
You have to have vitamin D in order to absorb calcium, which is why they put vitamin D in milk. And so that helps in the absorption of the calcium. So anyway, okay.
Little milk rant.
Yes, no problem. Okay, so we're going to talk about some of the major nutrients. Now, do you think we get most of our carbohydrates from animals or plants? Plants, right? Okay, this is where we get the carbohydrates. And so these would include starch, right? They would also include the glucose and sucrose, for example. Okay. Now, the major reason why we need carbohydrates is for energy production. Oops. And you will, if you pay attention, you know, sometimes you'll actually crave sugar when you're low blood sugar levels, because you need that glucose to produce energy, right? But we can store glucose as glycogen, right? So glucose is stored as glycogen in not only the liver, but it's also stored in the muscles. Okay. So we need that as a source of energy. One of the problems, however, is if you take in excessive carbohydrates, this causes the body to store the energy as fat. Okay, so this can lead to obesity. You know, excessive intake of any nutrients, even proteins, can be stored as fat. The reason why we store things as fat is that fat is water repelling, so it's hydrophobic, and so it can be stored in very concentrated forms. So the way that we store it as fat is in the form of triglycerides in adipose tissue. So adipose tissue is fat tissue. Triglycerides are the type of fats that we use to store, right? We store energy in triglycerides. There's other types of lipids which we'll talk about in a minute. Okay. Oh, I did want to point out this. This is kind of interesting. So there is this idea that a calorie is a calorie. So it doesn't matter if you take in 1,000 calories of potato chips or 1,000 calories of steak, right? It's the same. So there's this idea that calories are all the same. So the question is, are all calories the same? Okay. So when you're trying to lose weight, does it really matter if you get, as you know, you need your nutrients, but it doesn't really matter if I decide to eat potatoes and then I decide not to eat maybe almonds, right? So I choose to eat my calories in potatoes versus my calories in almonds. And so one of the things that they've discovered is that specifically, and this is kind of high fructose corn syrup lecture, is that high fructose corn syrup versus table sugar. So those are the two things that they were comparing. And so they gave them to the rats. And what they found is even if they gave them the exact same amount of calories in high fructose corn syrup versus sugar, they actually gained more weight, right? So high fructose corn syrup causes you to produce abdominal fat, specifically the type of fat that is in the abdominal cavity underneath your muscle. So think the big bellies, right, instead of subcutaneous fat, okay? And that it also caused a rise in triglyceride levels, right? And so this tells us that not all calories are the same. So if you were going to have a soda pop, it's best to have a soda pop that has cane sugar in it. They're more expensive versus the soda pops that have the high fructose corn syrup. Even if they are the same amount of calories, the one with the high fructose corn syrup is going to make you possibly gain more fat than one that has the corn syrup or has the cane sugar in it.
Now, are they talking?
So we'll put no.
Is it like? Are you saying if it's natural high fructose corn syrup, which obviously your body doesn't know the difference, but say that person was to eliminate drinking soda or eating, like fruit snacks and stuff that are going to be higher in it because they went through that whole, advertising and everything, whatever. But is it different if you were to eat nothing but fruits and vegetables and have that intake versus table sugar? Like, are they?
For some reason, the high fructose has more fruit. So I think it would be hard for you to consume enough fruit. Like, I wonder how many apples would be the equivalent of one Pepsi.
Okay.
Yeah. I don't know.
Probably, yeah.
So I'm not sure what the difference is between the high fructose, it's more concentrated or what. But remember, fructose is metabolized where? Liver, right? It cannot be metabolized in your cells. It's only in the liver. So for some reason, the way that the liver handles it is it produces more energy per unit of fructose corn syrup than it does per unit of other types of sugars. Yep. Okay, so we will stop there for today and we'll finish up and maybe have some time for review on midterm, which is a week from today. So excited.
Did you do right time?
We made second chapter.
And of course, we'll eat lots of coffee stuff.
Oh, nice.
Lots of
I'm gonna
candy at the
with-
party.
No,
I think
Danielle. Of course not. I'm just feeling.
I know. My husband brought home